I will speak about a new technology which is actually developed in our research lab in Palaiso. So um, we are developing, in fact, new kind of inertial sensor to be used when GPS or the other navigation positioning systems that you use is failed or have been hacked or jammed. So this kind of inertial technology are very useful for navigation of car, coach, or any vehicle that you want to know its positions. So this sensor, in fact, measures the acceleration and rotation of this vehicle, and the knowledge of this acceleration and rotation allow you to compute the position of this vehicle all along its motions, in fact. So, I'm sorry. And now to allow very long autonomous navigation time, like few days to 1 month, the accuracy of this sensor is very a key point. In fact, the longer the more accurate are your sensors, the longer navigation time you can have without need to recalibrate your system from another system like a GPS or a navigation or a radio navigation beacon. And to realize this kind of sensor, currently in the lab I'm working on a new technology which is called cold atom. So I will try to explain you what is this new technology. So first I need to explain you what is a hot atom, in fact, to explain you what is cold matter. So an hot atom, this is simply an atom, like every atoms you have in this room, but which is moving very fast and it's have a huge random motions. And in comparison, a cold atom does not have this huge random motion. This is simply an atom at rest. So for us to cool down atoms, this is simply to dump. So for us to cool down atoms, this is simply to dump these random motions. And just to be a little more specific about the temperatures that we reach, this is something like 1 millionth of a degree just above the absolute 0 degree temperatures, which is the temperature when nothing moves. Oh, okay, sorry. And to cool down this atom, we don't use a system with very complicated cryogenic system using liquid helium, for example. We only use laser light, and we shine our atom with this laser light, and this laser light apply a huge friction force to this atom, so we dump their motions. And when our atoms are cold enough, we can manipulate them according to the law of quantum mechanics. And if you manipulate them in a clever way, you can realize accelerometer and gyroscope and you can also realize clock with these atoms. And demonstrator of such sensor have already been made in academic lab, and they have shown very good performances, which are already better than their classical counterpart, in fact. But as you see in this kind of pictures where you have here a clock coming from academic lab and an accelerometer here, these are very complicated systems. They are still huge for two main reasons. Because first, they use a lot of optics for the atom coolings, and also because they use a huge vacuum chamber as a vessel to contain the atoms that are cooled down. And today, we are not focusing on having better performances because they are already very good. We try to compact, in fact, every part of this sensor to have it in an application, because like this you cannot use it. So and we try to go to something like few liter in terms of volume, which is still a good progress. And to compact them, we try to use two main technology. The first one is what we call an atom chip, and an atom chip you have here. You have one on this picture. This is simply an insulating substrate with conductive wire, and this wire allows you to trap your atom and to realize all the measurements that we want to do. And this stay compact because you simply have one chip of 1 centimeter square approximately. And to create all the lasers that we need to have for this atom cooling and manipulation, we try to implement all this light manipulation with photonic integrated circuits, which is a technology which comes from the telecom, and which allow you to create the light and to shine your atom with this light, to cool them down and to manipulate and to realize the measurements. So, so to explain you what is To conclude, this is in fact a very promising technology. This is still a future technology, but this is a very promising technology. We could be very useful, in fact, as a backup solutions when your other navigation system does not work. You can have this solution running in parallel from your other navigation and know if your current navigation system works properly or not. Or as they are very accurate, you can also use them for standalone navigation as a standalone system, simply to compute your position and to know exactly where you are.